We will look at the solution to tutorial question 7 in functions 2. The first part requires us to state how the sketch shows that each f is not 1, 1. Looking at the sketch, in order to show that, all we have to do is a horizontal line test. We can state that since the line y equals to 2 casts the graph of y equals to hfx at 2 points, hf is not 1, 1. Some notes. You only need to show one horizontal line that casts the graph at more than 1 point. There is no need to show the general line y equals to k. You can use any horizontal line that casts the graph at more than 1 point. For example, y equals to 1, y equals to 10, all are okay. Do take note of the expressions that you use. It is graph of y equals to hfx, not graph of hf. And also it is function hf, not function hfx, or function y equals to hfx. Next part, we need to show that if alpha and beta, where alpha is in between 0 and beta, such that hf alpha equals to hf beta, then alpha equals to g beta. This looks like a complicated question at first glance, but if we unpack the information given in the question, we can realize that what we need to do is pretty simple. So what are the information in the question? First, from the fact that alpha is between 0 and beta, we know that alpha and beta are different values, where both are positive and alpha is smaller than beta. Next, given that hf alpha equals to hf beta, we know that alpha and beta give the same y value in the graph of y equals to hfx, like this. Next, what do we need to show? We need to show that alpha equals to g beta, whereby based on the function g, what we need to show is that alpha equals to 1 over beta. Now, let's see how this could be done. First, let's find what is the function hfx. Doing a composite of the two functions, we get that hfx equals to ln x squared. Since we are told that hf alpha equals to hf beta, in other words, we know that ln of alpha squared equals to ln of beta squared. Taking square root on both sides, we can reach ln alpha equals to plus minus ln beta. Take note of the plus minus here. And since alpha is smaller than beta, we know that ln alpha cannot be equal to ln beta. Why is this show? Because the ln function is a 1, 1 function. As seen in this graph of y equals to ln x, if alpha and beta are two separate values, then ln alpha will be a separate value from ln beta. What does this mean? This means that my ln alpha must be equals to negative ln beta. From here, using the law of logarithm, I know that ln alpha can also be equals to ln of beta to the power of negative 1, or ln alpha equals to ln 1 over beta, and hence we have shown alpha equals to 1 over beta. For the next part, we are required to sketch a graph of 5 inverse. First, the part of the function 5 is just the portion of hfx from 0 to 1, as highlighted in the graph. So, to draw the graph of phi inverse, it will look like this. The last part, we need to give an explicit expression in terms of x for phi inverse x. Since phi x equals to hfx, which we have shown earlier to be ln x squared, but do take note that for this case, x is only between 0 and 1. To find the inverse, we will go through the usual process. Let y equals to ln x squared. This will give us ln x equals to plus minus square root y. Again, do take note of the plus minus. So, which one do we choose? Positive square root y or negative square root y? In order to do this, we have to remember that x belongs to between 0 and 1 in this case. And from the graph of ln x, we know that for x values between 0 and 1, ln x in fact is less than or equals to 0. This will tell us that my ln x must be equals to negative square root y. From here, making x a subject, we get e to the power of negative square root y. And hence, my inverse function, phi inverse x, must be equals to e to the power of negative square root x. Now, can you state the domain of phi inverse? The domain is the same as the range of phi, which if you look back at the graph of hfx, that will be from 0 to infinity, where 0 is included.